at the problem we stopped at yesterday. And we were asked to determine whether the answer that was given for this was correct. And we're supposed to do it both algebraically and graphically. So they gave us an answer of, we'll put it up over here, 2, 5. So it's pretty easy to tell that that's not the correct answer, because if you come over here and you make this 3 times 2 minus 5 equals 2, you end up with 6 minus 5 equals 2, and of course 1 does not equal 2. So right away you know it's not correct. You could put it down here as well if you wanted, and you'd have 2 plus 4 times 5 equals 32, and of course you end up with 2 plus 20 equals 32, and of course 22 does not equal 32. Okay, so right there at the with the bottom one here, by putting 2 and 5 into the equation, and up here with the top one putting 2 and 5, we've shown that that is not the solution to the system of linear equations. So the thing about that is that at that point there's really you wouldn't need to graph it to prove that it was wrong, because you already know that it's wrong. However, you could still go ahead and graph it, and I don't know if you remember this, but we found that we did the x and y intercepts. We let, for example, here we let x equal 0, and so we knew that y had to be 8. That was going to be our y intercept. And then we let y equal 0, and therefore we knew that x was going to have to be 32. Okay? So, and then up here, we let y equals 0. You end up with 3x equals 2, and therefore x intercept ended up being 2/3. And then if you let x equal 0, you end up with negative y equals 2. You multiply both sides by negative 1, and you ended up with y equals negative 2. So one of the problems we had was that the graph yesterday only went up to 10. So I've taken the time to graph this, and keep it in mind that we've got, for this equation, the x and y intercepts, after making x and y equal to 0, that's how you found them. X is 2/3, y is negative 2. Down here we have 8 and 32. So let's take a quick peek at what that looks like. It looks like this. Okay, so on this particular graph, each one of these boxes is worth 2. So you can see I've got on the 16th box over here, I've got the 32. And over here, I'm 4 boxes up, and that's 8. Down here, I'm at negative 2 because each box is worth 2. And even though that looks like 1/3, it's actually 2/3 because this box is 2. And here you can see the limitation of graphing to find a solution to a system of linear equations. The actual answer, and I did it algebraically, and we're going to teach you in Unit 9 how to find the answer when graphing is not a good way of doing it. But you can see the problem here. Look at where the two lines meet. It's somewhere between 2 and 4, because it's between the 2 and 4 boxes here, and it's somewhere between 7 and 8 because this is the 6 box, or this is number 6, that's number 8. But the reality is there is no way for unless you have a supercomputer brain in your head, there's no way to know what this actual intersection is, because it's a fraction. And look at it, it's 3 and 1/3, 7 and 3/13. This is actually not too difficult to figure out algebraically, either using something called substitution or elimination, but it would be next to impossible to determine if you were to graph this. So this question turned out to be kind of interesting in a way, because it showed you the limitations of graphing when you're trying to solve a system of linear equations. All right? Okay, I'll see you in the next class meeting. Bye-bye.